What's up guys, welcome back to another video. In this session I will be going over 10 exercises where we calculate the derivative of any combination of powers of x, so derivatives of polynomials. These exercises will start out very basic at the start and will get progressively more difficult towards the end. Feel free to skip around depending on your own level. The timestamps of each exercise is given in the comments and in the description below. As always, these videos focus on the step-by-step approach, where I explain each step I do along the way, so that you don't feel like you're missing out or get confused at any point. So with that out of the way, let's get into it. The general form I've written here of a derivative of the power of x, let's say for x to the power of n, is just n times x to the power of n minus 1. This is a general form we have to keep in mind while solving these exercises. Let's look at a first exercise, which is the derivative of x squared, so x to the power of 2. This simply becomes 2 times x to the power of 2 minus 1, because according to the general formula, the exponent of x drops by 1. So this is simply 2 times x to the power of 1, and x to the power of 1 is simply x. So our result is 2x. The next exercise is the derivative of x squared plus x. What we know from derivatives is that the derivative of a sum of functions, so a sum of, in this case, x squared plus x, is equal to the derivative, or it's equal to the sum of derivatives. So it's the derivative of x squared plus the derivative of x. So the derivative just gets divided over the different parts of the sum. And now we can just simply use our general formula. The derivative of x squared is 2 times, because the exponent drops down, x to the power of 2 minus 1, because the exponent gets reduced by 1. Plus, here we have a 1 in the exponent, so this basically is x to the power of 1. So 1 drops down times x to the exponent of 1 minus 1, which is 2 times x to the power of 1 plus x to the power of 0, which is basically 2 times x, because x to the power of 1 is x, plus 1, because x to the power of 0 is 1. The next exercise is the derivative of x times 3x to the power of 5 minus 6. Again, here we see that we have this minus sign here, so we want to divide the derivative so that we only have one x for each derivative. So this is equal to, let's first simplify what we have between brackets. So we want to rewrite this. This x gets multiplied by this 3x to the power of 5. So we get x times 3x to the power of 5. Then we want to do this multiplication, which is basically minus x times 6. Then we just rewrite it a little bit more. So we get 3x to the power of 6, because we get that x times x to the power of 5 is x to the power of 5 plus 1 is x to the power of 6. Just as an aside, minus 6x. And now we can use the property that the derivative of a sum or a subtraction is the sum of the derivatives. So we get d over dx of 3x to the power of 6 minus d over dx of 6x. And now we can use our general formula. So this 6 drops down, which then becomes 3 times 6 times x to the power of 6 minus 1, because the exponent drops by 1, minus 6 times x to the power of 0, because here we actually have x to the power of 1, which is just x, and 1 minus 1 is 0. So we get 18 times x to the power of 5 minus 6, because x to the power of 0 is just 1. And there we already have our answer. The next exercise, we are going to look at the derivative of 1 divided by x squared. So now our x is in the denominator. So let's see how we approach such exercises. What we want to do is write this expression of x as some form of x to the power of a number. And we know that if we just have 1 over x, that this becomes x to the power of minus 1. So let me write that down. So 1 over x can be written as x to the power of minus 1. The same is true if this x in the denominator has an exponent. So let's see what it becomes here. So this 1 over x squared can be written as x to the power of minus 2. And now we just have our general form here, but now with n is equal to minus 2. So we can just use the rule that we always used, which is just minus 2, because this 2 here drops in front of it, times x to the power of minus 2 minus 1. And this minus 1 just comes from the fact that our exponent gets subtracted by 1. And then we just do this basic calculation. We get 2x to the power of minus 3, which then again be written as minus 2 times 1 over x to the power of 3. So that's our result. The next exercise will be a little bit more difficult, but we'll be able to do it. So the derivative of x plus 2x to the power of 3 divided by 2x to the power of 4. So now the exercises are starting to look quite complicated. But if we just use our algebraic rules and our general formula for the derivative of a power of x, we will get the right result. Let's see how we're going to do this. So first, again, we see that we have this plus sign here. So we want to use the fact that the derivative of a sum is the sum of the derivatives. So let's split this entire fraction. So we get d over dx of x divided by 2x to the power of 4 plus 2x to the power of 3 divided by 2x to the power of 4. Now we can still rewrite or simplify these expressions, these fractions. So let's do that before we do the derivative. So this x and this x cancels, and this x in the denominator drops 1 power. So this becomes 1 over 2x to the power of 3 plus the same can be done here. So here we, in the numerator, we cancel 3 powers of x, which also cancels here, and only 1 power is left in the denominator. This 2 also cancels, so we get 1 divided by x to the power of 1, which is of course x. So now we can split our derivative. So we get d over dx of first 1 over 2x to the power of 3 plus d over dx of 1 over x. And now we will still rewrite this in the form of x to the power of n. This can be simply done by doing this. D over dx of 1/2 times x to the power of minus 3 plus d over dx of x to the power of minus 1. Again, using this property that if the x is in the denominator, we just have that it is in x in the numerator, but the exponent has a minus sign in front of it. And now we can finally do our derivatives, which becomes 1/2. That's just, well, that stays the same. This minus 3 drops in front of it. So we get minus 3 times x to the power of minus 3 minus 1, because it's subtracted by 1, plus minus 1, since this minus 1 gets dropped in front, times x to the power of minus 1, because it gets subtracted by 1. And now we just rewrite this. So we get minus 3 over 2 x to the power of minus 4 minus x to the power of minus 2, which is just minus 3 divided by 2 to the power of 4 minus 1 over x to the power of 2. And we have our result of our initial exercise, which looked quite complicated already. The next exercise will be handling square roots. And we'll see that this is just a special case of the general form that we already know. Let's look at the derivative of the square root of x. The thing that we need to know here is that the square root of x can be written as x to the power of 1/2. This is just a way to rewrite it. In the same way, the third root of x is equal to x to the power of 1/3. And if you want to make it really complicated, the third root of x to the power of 5, for example, is just x to the power of 5 divided by 3. We can get something general from this, that the power that is on the x inside of the root goes here, and the power of the root itself goes here. Knowing this, we can just solve the derivative of the square root of x, because this simply becomes the derivative of x to the power of 1/2. And we can just as easily use our general form here again, which becomes 1/2, because the exponent drops in front of it, times x to the power of 1/2 minus 1, because the exponent gets subtracted by 1. Rewriting this, we get 1/2 times x to the power of minus 1/2. And here we combine two exponent properties in one. We have this minus sign, which says that the x actually has to be in the denominator. And we have this 1/2, which says that it has to be a square. So let's do this step by step. So we get 1/2 times 1 over x to the power of 1/2, because the minus sign makes it go into the denominator, which is equal to 1 over 2 times 1 over the square root of x, because x to the power of 1/2 is the square root of x. And there we have our result. So the derivative of the square root of x is 1/2 times 1 over the square root of x. With that done, let's go to the next exercise. And from this point, they will get quite difficult. But if you just keep to the general formula, you will be able to solve them. D over dx, so the derivative of the third root of x plus 1 over 2x. So step 1 is to rewrite everything as a power of x. So this becomes d over dx of x to the power of 1/3 plus 1/2 x to the power of minus 1. Now we can use a property that the derivative of a sum is the sum of the derivatives. So we get d over dx of x to the power of 1/3 plus d over dx of 1/2 times x to the power of minus 1. And now we will just use our general formula for each of these terms. So we get 1/3, because this exponent drops in front, times x to the power of 1/3 minus 1, plus 1/2 times minus 1, because this exponent drops in front, times x to the power of minus 1 minus 1, because it gets subtracted by 1. So we have 1/3 times x to the power of minus 2/3 minus 1/2 times x to the power of minus 2. And we can just write the solution like this, so just leave it as it is, or you can do it as an exercise to write it in a form of fractions and roots. But we'll be going to the next exercise. So the second to last exercise, which is quite complex already, but we'll be going through it step by step, is the derivative of x to the power of 3 times the square root of x to the power of 3 divided by 5x. How do we tackle such a problem? We want to write this as the derivative of a single power of x. But how do we write all these different terms in this fraction into one? Let's use the property that x to the power of a times x to the power of b is just x to the power of a plus b. Likewise, x to the power of a divided by x to the power of b is x to the power of a minus b. So let's use these properties here. So let's first rewrite this so we can take the derivative. So we get x to the power of 3, we can just leave that as it is. Then the square root of the third power of x, we can write in the following way. So we have x to the power of 3 to the power of 1/2, because the square root is basically taking the thing that is inside of the square root, in this case x to the power of 3, and lift it to the power of 1/2, divided by 5x. What we can do now is use the property that x to the power of a to the power of b is equal to x to the power of a times b, which is notably different from this one. So we get d over dx of x to the power of 3 times x to the power of 3/2, because this 3 here gets multiplied by this 1/2, which gives 3/2, and we divide it by 5x. Rewriting it even further, we get the derivative of x to the power of 3 plus 3/2 divided by 5x, which is equal to the derivative of x to the power of 6/2, which is this 3. So I just rewrite this 3 as 6/2, plus 3/2, which is this exponent. And I divide this by 5x, which is equal to d over dx of x to the power of 9 divided by 2 divided by 5x. And we're almost there. Let me just rewrite it one step further. So this is d over dx. So the derivative of x to the power of 9 divided by 2 times x to the power of minus 1 divided by 5. And what I did here is write this x in the denominator to this x to the minus 1 in the numerator, which is d over dx of x to the power of 9 divided by 2 minus 1 divided by 5. And now we're there, because we see that we have one exponent in x left. So we have x to the power of 7/2 divided by 5. And what did I do here? I just did 9/2 minus 1, which is 7/2. And this finally gives our answer. So we got 1 divided by 5 times 7 divided by 2, because this exponent drops in front, times x to the power of 7/2 minus 1, because the exponent gets subtracted by 1. Rewriting this, we get 7 divided by 10 times x to the power of 5/2. And we finally have our answer to this, well, complicated exercise of the derivative of this combination of powers of x. Let's now do one final very difficult exercise. And if you can do this exercise, then you can be sure that you can do any exercise where you have to derive powers of x. So we have d over dx, x to the power of 5 times square root of x minus x to the power of minus 3 times the fifth root of x to the power of 3. And we divide this all by x. This does look quite complicated. However, when we just take the same steps as we did before, then we'll perfectly get there. So what do we do first? We try to rewrite some powers of x. So d over dx, we leave that for at the end of the exercise. And we rewrite the powers of x, such as the square roots, we just rewrite them. So we get x to the power of 5, which we just leave as this. This square root we write as x to the power of 1/2 minus x to the power of minus 3 times x to the power of 3 divided by 5. And this basically comes from this 3 is a 3 that is at the x under the root. And we have that this 5 is the root itself divided by x. And now we're already halfway done, because we can just rewrite this even further, which is x to the power of 5 plus 1/2 minus x to the power of minus 3 plus 3 over 5 divided by x, which is equal to d over dx of x to the power of 11 divided by 2 minus x to the power of minus 12 over 5 divided by x. And what I did in this step is just doing 5 plus 1/2, which is 10 over 2 plus 1 over 2, which is 11 over 2 for this first exponent. And minus 3 plus 3 over 5 is minus 15 over 5 plus 3 over 5 is minus 12 over 5 for this last exponent. Now we use that the derivative of a sum or a subtraction is the sum of the derivatives. So let's look how this works. So this d over dx of x to the power of 11 divided by 2 divided by x minus the derivative of x to the power of minus 12 divided by 5 over x. Rewriting this as one of the final steps is x to the power of 11 divided by 2 times x to the minus 1 minus the derivative of x to the power of minus 12 divided by 5 times x to the minus 1. Just basically rewriting this x in the denominator as an x to the negative 1 in the numerator. So we get that the derivative of x to the power of 9 over 2, which is 11/2 minus 1, minus the derivative of x to the power of minus 17 divided by 5, which is basically minus 12 divided by 5 minus 5 divided by 5, which is this 1 here, which is minus 17 divided by 5. And now we can finally do our derivatives. So we get that this becomes 9 over 2, because this exponent gets in front, times x to the power of 7 over 2, which is basically 9 over 2 minus 1, which is 7 over 2, minus 17 over 5 gets in front, that's this one. And here we have to take care of this double minus sign. We don't have to, well, we shouldn't be confused about it. Times x to the power of minus 22 divided by 5, which is basically this minus 17 divided by 5 minus 1. So minus 5 divided by 5. And there you have it. Let me just rewrite it one last time. So 9/2 x to the power of 7 divided by 2 plus 17 divided by 5 x to the power of minus 22 divided by 5, And this is our final answer. So this brings us to the end of the session, and I hope that you learned something. And if you did, please consider giving this video a like, because this increases the likelihood that other people struggling with these topics find these videos and might be helped. And of course, I will be continuing to uploading videos like these, so also consider subscribing if you want to be notified for upcoming videos. And with that, I hope you have a nice day and see you in the next one. Bye.